Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Peracids, peroxyacids, such as mCPBA or CH3CO3H, peracetic acid, react with alkenes via electrophilic epoxidation. The peracid donates an oxygen to the pi bond in a concerted SYN addition mechanism, forming an epoxide, oxirane, without ring opening. Moving on to the next step. CH3CO3H is peracetic acid, a peroxyacid. Peroxyacids are classic epoxidation reagents for alkenes. Moving on to the next step. 1-methylcyclopentene contains a trisubstituted double bond between C1, bearing the methyl group, and C2 of the cyclopentane ring. And for the final step, the peracid transfers its terminal oxygen to the double bond in a concerted butterfly transition state. This gives direct epoxidation. The two carbons of the double bond become the epoxide carbons with oxygen bridging them. No carbocation intermediate is formed, and no water is involved, so no diol is formed directly. The product is 1-methyl 1,2-epoxycyclopentane, i.e., a cyclopentane ring with an epoxide oxygen bridge across C1, C2 and a methyl group at C1. This corresponds to option C, which shows a cyclopentane ring with a CH3 group at C1 and an epoxide oxygen bridging C1 and C2. Option A shows a trans 1-methyl-2-cyclopentanol, which would result from acid-catalyzed ring opening of the epoxide with water, not direct peracid treatment. Option B shows a product where O and CH3 appear on the same carbon, inconsistent with epoxidation of 1-methylcyclopentene. Option D shows a CIS 1-methyl-2-cyclopentanol, again a ring-opened product, not the direct epoxidation product. The direct product of peracid epoxidation is the epoxide itself, not the opened diol or alcohol. Therefore, the correct answer is C. Therefore, the correct answer is option C.